Okay, so let's start with the Leetcode daily challenge of 16th Feb 2025. Fine, let's go to the question. And it is construct the lexicographically largest valid sequence. So, kind of we have to create some sequence which is lexicographically largest. Let's get into the details, which is that we are given an integer n. Okay, integer n is given, and we have to find a sequence with this. In that sequence, integer 1 should occur only once. Each integer between 2 to n means the rest of the integers occurs twice in the sequence. Only one occurs one in the sequence. So we can think from that the sequence has a length 2 times of n minus 1, because if 1 would have occurred 2 times, then every integer would have occurred 2 times. So it would have been 2n, but 1 is occurring only one time, so it will be 2n minus 1. And for every integer I between 2 and n, the distance between the two occurrences of I is exactly I. Okay, the distance between the two occurrences of I is exactly I. So whatever integer is occurring 2 times, the distance between its two occurrence is the number itself. Like if 3 is occurring in the, obviously 1 2 3 are in the sequence. 1 will be only one time, 2 will be 2 times, 3 will be 2 times. Total length is 5. So if 3 is here, 3 is here, the next 3 will be from the third position from there. So 1 2 3 here. If 2 is here, next 2 will be 2 positions next. So 1 and 2. Similarly 5 is there, then 1 2 3 4 5. Next 5 is at the fifth position from this position. Okay, that's how it works. And okay, the distance between any two sequence is basically okay. Return the lexicographically largest. Yeah, lexicographically largest sequence. If A is lexicographically largest than B, it means that if n is the first position where A and B differ, then sequence A has a number greater than the corresponding number in B. Yeah. So so basically we have to put the numbers on some respective positions and check if it satisfies these conditions of the questions, right? And when we have a full sequence ready, we have used all the numbers, we will return the answer, kind of that, right? And if this bells are ring, like it matches, it similarizes itself to backtracking questions somehow, because we here need to like find all the possibilities of the numbers, like where they can be, and if that gives us the right result, then we will return it. If not, we will backtrack, right? It's not always safe to say that one number if we put here, well, let's say if 3 we put here, next 3 is here, we should put 2 then, right, for the lexicographically largest. So if we put 2 here, the next two will be here, right? And it cannot be here, it cannot be here. So now we have tried to put 2 here, but 2 cannot be put here, next 2 cannot be put here. So we will backtrack, means we will try another number here, which is 1. That's how we have to do. Like, we need to find the possibilities, and then in lexicographical order, obviously. And then if that's not true, like going forward at some place it fails, then we will backtrack and try some other number at its place. And whenever we find we got the whole sequence covered, we have used all the numbers, all the length, then we have answer and we'll return it. That will be the lexicographical largest. Okay, so backtracking is the basics. Now for backtracking, let's take the final answer firstly. Yeah, this is the final answer we're gonna return. And let's take a vector which will be basically the combination in progress which we are making. If it if it is made completely, we have created this sequence, we will assign it to the answer and then return the answer. Okay, that will be like temporary, we can say, and its length is 2 times of n minus 1. And for each number, that if it has been used in the vector or answer or not, we'll take a boolean, means basically visited array, which will have size n plus 1 for all the numbers and numbers. Okay, okay, so this is it. Yeah, fine. Now we'll call that function. Let's call this solve. See, what we will give here is first is the index. We have 2 and minus 1 indexes available, right? And n numbers available. So we will throw the largest number first. Then try to put it at index 0. With answer we will give, temp we will give, and visited we will give. Okay, and then return the answer. So basically what this recursive call suggests is that this will be a recursion, obviously backtracking we are doing. We are trying to put this number at this index. If not possible, we will go for the next index. If number is put successfully, then we will go for n minus 1 and 0 plus 1, right? Just like this. Okay, so we will now do void solve int number int index and vector and answer, vector int and temp, vector bool and visited. Yeah, fine. Now the next thing will be firstly we should write the stopping condition, but oh, if we already have the answer, we are not going to call this function, right? So first thing is, if I is 0, means all the numbers are done. I started from number started from n and it reaches 0, means from 1 to n all numbers are used, we have done all of them. Then we will answer will be equal to the temp, right? Else if this index is already written with something, because see, what we are gonna do is, whenever we are writing one number at an index, we are also going to write its second occurrence right at that moment only. Okay, we are filling both the occurrence of that number at once. We are not going to come again for the second occurrence. Okay, we are filling one occurrence and filling the second occurrence at the same place at the same time, right? So if a position is already filled, it's possible that it's already filled with someone other's second occurrence already, because we go to the another index which is lot ahead of the current index to fill the second occurrence. Like if current index is 5, we go to 5 index ahead to fill next 5, right? So we fill the index in advance, so it might happen that when we go to that index, we need to check if something is there or not. If something is not there, then we'll go forward, right? If something is there, we will not do anything. So if temp of I is something, we will just call the function for next index, that this is filled, go to the next one. Okay, and the rest of the things being same, fine. And one more thing, if we have the answer, if we have the answer uh, if we have the answer and we have the answer, right? And index is Index is wait, we can write this that these can be transferred here. If the answer is find and I index is less or equal to temp dot size, see if the answer is not found and index is valid, then only we will go to solve something, otherwise we will not do anything, right? If we have already the answer, we have found the answer size is not 0, then we have got the answer. Obviously we don't need to do anything. And if I is greater than temp dot size, means in index is out of range, out of bounds, then also it's invalid to solve anything, right? Now this two condition else, if that index is empty and number is not 0, then we will do what is, we will run a for loop where we will start from the last element, we will go up to greater than 0 and we'll go j minus minus, we will try to put all the numbers from n to 0 over this specific position, right? So if this number is not, see when we will put this number, when this number is not visited, right? So this number is not visited, correct? Second condition being, and the next occurrence index is within the bounds, means current number is what, j, and current index is I. So I plus j is the next index of its occurrence, next occurrence, right? It should be less than temp dot size, it should be within the bounds, right? And second thing being, and that index should also be empty, right? This index should also be empty, I plus j, then this should also be empty. I think it's perfect. Or we can say any other in any other left, any other condition left. We have tried the visited ones. Yeah, okay. Yeah, one more thing. Uh, yeah, if j is equal to 1, then we don't need to like think about the next occurrence, correct? But it should be here, either this whole thing or j is equal to 1, either this, right? If this is the thing, then we don't need to think about 1, but if j is 1, then this whole thing should not be there, because for 1 we will not check the next index because its occurrence is only 1. Okay, if the conditions are satisfied, we have written down all the conditions we want to have in our sequence. Now we will do what, we will put to j at I index. Okay, we put j at I index, and if j is not equal to 1, if the j is not equal to 1, then we will put same number at the next index also, means the next occurrence index, means I plus j पे भी हम किसको रख देंगे, j को रख देंगे. Okay, if j is 1, then we have already put it, but if j is not 1, we have to put the number on the second occurrence also, right? So we will put it here, and then yeah, we will now make it visited, that visited of j is now true, that we have already visited it, and we will call the function now for next number, next integer, next index, basically answer temp and visited. Perfect. And now we'll backtrack that temp I, we again put 0. After calling the function we'll backtrack, right? And if j is not equal to 1, we will write temp I plus j uh, is equal to again 0, and we will make it visited as false. Basically it should be j is visited, right? The numbers visited, yeah, okay. We'll do this, and I think that's it, I guess. Okay, number, fine, I guess. Yeah, perfect. Let's see. Okay, it should be number basically, not n. No, it should be n. नंबर तो सारे ट्राई करेंगे ना उस पोजीशन के लिए, एक एक करके। लेक्सोग्राफिकली लार्जेस्ट करना है तो हम बड़े से शुरू करेंगे, छोटे ही तरफ जाएंगे। तो एन, एन हम बेसिकली लिख सकते हैं यहाँ पे, साइज़ लिख सकते हैं ना, साइज़ तो होगा ही। हाँ तो इसको ये लिख दो। नहीं यार, साइज़ भी नहीं होगा, एन तो हमें भेजना पड़ेगा। तो वी कैन सेंड एन हियर। This n is different, but this third n is size basically. Okay, third n is size, so we will send int size, we can say. Okay, then we can put it here also on in all the function calls, and we can write this as z. Fine. Yeah, it works fine. Let's try to submit it. Perfect. And it's giving 100%. Okay, that's cool. So yeah, this was the question for today. A pretty good one, but if once the backtracking hits our mind that it can be solved with backtracking, that's nothing. And one thing we need to keep in mind is that we need to fill both the occurrences at one time only. We cannot do like this time we will first the first occurrence, and second time for the same number we will turn another loop for filling the another occurrence. Don't do this. Fill at same time, so that when we go to that second index we know that it's already filled with the second occurrence of some number. It's not empty, and if it's not empty, then we will call this a function again with the next index, because this index is filled. Okay, so this is how we do. And why this is loop is running backwards is basically because we have to find the lexicographically largest. So we try to put the largest number at each um, position, but if that number is already visited we can't do that, it should be non-visited. Second thing, if that number has a second occurrence, means j is not equal to 1, then the second occurrence should be within the bounds, and the second index and the index of that second occurrence should be empty. Otherwise, if the j is 1, then we don't need to worry about these conditions, because we have to just worry about the current index, not the I plus jth index. And this whole thing is about the I plus jth index. And yeah, that's it. That's it for this question. Pretty standard one, we can say. Yeah, so that's it. Let's meet tomorrow with the day 10.